Hello, today I am glad to present our paper titled in A Potential New Sound Change After Tonogenesis, which is a preliminary study on the perception of tonal contrast in Weijun Chinese. First of all, I would like to introduce some background information. Wu Chinese is a Chinese language spoken in Southeast China and many diaspora Chinese communities with about 70 million native speakers. The tonogenesis in Wu Chinese, actually very similar with many Southeast Asian languages, involved a tonal split mechanism. The 4 tones of Middle Chinese develop into 8 tones of 2 tonal registers, high and low, by the onset consonantal voicing. But a very typical feature of Wu, which has disappeared in most Chinese languages, is that the phonological voicing contrast of Middle Chinese is still preserved. So the tone or pitch contrast and phonological voicing contrast actually coexist in a hand-in-hand relationship in Wu Chinese. Then regarding the voicing contrast of Wu, there's much literature addressing its phonetic nature in various dialects. For example, studies on Shanghai Wu shows that the phonological voicing contrast in the initial position is now actually realized as phonation type contrast in the vowel instead of true consonantal voicing. While in our previous production data on Weijun Wu, significant age variance could be observed. As the closed caution data obtained from electroglottography signal indicated here, the young speakers, similar with the aforementioned Shanghai speakers, realize the contrast by vowel breathness, while the old speakers did not use phonation type to make the contrast. Then let's have a look on the tones of Weijun Wu. Here firstly shows the tone inventory. If we pay attention to the tone paths in the same color, it could be found that the high and low register tones actually share totally identical contours with only slight tone value differences. And actually some studies ever mentioned that the difference between tone 3 and tone 4 or tone 7 and tone 8 is hardly perceptible for the informants. And in our production data, the pitch contrast across high and low registers, although still exists, not totally merged, but is indeed weakened in young speaker speech. So it seems that there is an ongoing sound change in production that the pitch contrast arising from tonogenesis is gradually replaced by the phonation type contrast, namely the breathiness of the vowel. Then of course there would be potential Q redundancy here, right? So the potential sound change in production and the Q redundancy mentioned would very naturally lead us to raise the research questions we want to explore in the current study. That is, what is or what are the cues that distinguish the tonal register of Weijun Wu for perception, and whether the speakers of different age groups also use different cues in perception. Then we recruited 8 old and 12 young native speakers with large age difference to do a 2 alternative forced choice task. The materials for resynthesis was recorded by a 26-year-old young speaker, but contrasted in both tonal register and phonation type. Stops of all places of articulation were included, and we only used the level tone pad this time. Then the 6 tokens were all resynthesized into a 12-step pitch continuum with equal semitone steps. And the phonation type of vowels were not changed in stimuli resynthesis. All of the participants will listen to 3 repetitions in random order, and the response and reaction time were recorded. Now, let me show the results of percentage of response first. This is a response for tokens supposed to have low register tones. In other words, the vowel is breathy voiced. The resynthesized pitch step 1 in the figure represents the low end of the pitch continuum, and step 12 the high end. There's very robust age variance, right? That the old speakers strongly relied on pitch, since the negative correlation between the percentage of low tone response and the pitch basically shows a typical continuous perception pattern. While the young speakers' percentage of response changed much slower, although the percentage also decreased as the pitch rose up, it was still consistently higher than 50%, the chance level. So we can conclude that the pitch is still used as at least one of the perceptual cues by all speakers, as the percentage of response always fell down to different extents as pitch increased, but the age variance is in cue weighting, that pitch plays a way more prominent role in old speakers' perception. Then this is the response patterns for tokens supposed to have high register tones, that is with modal vowels. The two groups of participants showed quite similar patterns this time. Regardless of the pitch height, all participants consistently had a bias to high register tones. Although the percentage also showed general decline curves as pitch decreased, and particularly in pitch steps ranging from 12 to 8, both groups of participants could reach extremely high perceptual certainty with almost no effective pitch. Then, if we compare the two figures together, an asymmetry between the old speakers' patterns of response could be found. So it could be concluded that both vowel breathiness and low pitch are necessary for old speakers to perceive low register tones. Either only vowel breathiness or only low pitch is not adequate. Vowel breathiness undeniably has become an important cue for old speakers perceiving low tones, at least when they listen to young speakers' speech. As our stimuli were recorded by a young speaker, right? As I mentioned, even though the old speakers do not produce phonation type difference in their own production, they do to some extent use it in perception. Then for young speakers, the story is simpler. That the difference between breathy vowels and modal vowels has become the most significant perceptual cue. And pitch still serves as an influential factor, but totally not as important as it is for old speakers. Then let us see the results of reaction time now. This is the reaction time pattern for the low register tone tokens with breathy vowels. From pitch steps 1 to 7, no group difference could be observed. The reaction time just increased as expected when pitch increased, whereas the reaction time curves of old and young speakers became increasingly further apart when the pitch rose to step 8 or above, where the old speakers had even faster reaction, which seems to be unexpected. However, if we combine this figure together with the pattern of response, we can easily find that the time of percentage of the response falling below chance level is exactly when the old speakers decreased in reaction time. So since they had perceived the step 8 and above as high register tones, the cue conflict actually decreased when pitch rose up, and hence the perceptual uncertainty decreased as well. While for the young speakers, as they still perceived them as low register tones, the further rising of pitch kept intensifying the cue conflict and also perceptual uncertainty. Then the reaction time pattern of high register tone tokens with modal vowels is simpler. As the old and young speakers also showed similar patterns in percentage of response as mentioned, the patterns for reaction time of the two groups were not very different as well. Basically, the young speakers just have shorter reaction time than old speakers generally, as expected, especially during the mid-pitch steps. So now we can draw the conclusion as the answer to the two research questions. Yes, age variation does exist on the perceptual cue in perceiving the high and low tonal contrast in Weijun Chinese. For the old speakers, both low pitch and vowel breathiness are needed for the perception of the low register tone, at least when perceiving young speakers' voice. Any type of the cue conflict, including high pitch with breathy vowel or low pitch with modal vowel, will lead to a bias in perception to the high register tones. And for young speakers, phonation type has definitely been the most primary perceptual cue for tonal contrast, and the cue weighting of pitch has been decreased to a large extent. So naturally, the The age variance showed in synchronic data may suggest a potential diachronic change in progress, that the vowel phonation type is playing an increasingly important role in distinguishing this contrast, which is consistent with the change of acoustic correlates of the contrast happening in production, as we mentioned at the beginning, right? Therefore, a potential new stage after tonogenesis could be reasonably predicted in both production and perception, that the phonetic realization of the contrast has changed from consonantal voicing to pitch and now may possibly further change to vowel phonation. The parameters listed here are all used to realize a single phonological contrast in Wu. But what is the internal interaction mechanism among these closely related parameters leading to the phonetic compensation phenomenon we observed is still largely unexplored and should be a further question studied. Okay, and that is all for my presentation, and thanks for watching. Here's my email, and all comments and discussions are the most welcome. Thank you.